DTFT stands for Discrete Time Fourier Transform. DTFT stands for Discrete Time Fourier Transform. And what the need for DTFT, why this DTFT is required. We already know Fourier series and Fourier transform are two different things. Fourier series and Fourier transform are two different things. Coming to DTFT, the expansion is discrete time Fourier transform. Discrete time Fourier transform. And we have discrete time Fourier series, discrete time Fourier transform. This is applied for periodic signals. This is for periodic signals. And DTFT is for aperiodic. This is for aperiodic signals. This is for aperiodic signals. First one is for periodic. First one is for periodic signals. I think should be writing this again. Okay. First one is for DTFS is for periodic signals. DTFT is for aperiodic signals. Okay. So we have something called Dirichlet conditions. Dirichlet conditions. The thing is, signal should have finite number of maxima minima, finite number of maxima minima, finite number of discontinuities, finite number of discontinuities, jumps, finite number of discontinuities, and signal should be absolutely integrable. Signal should be absolutely integrable. These are the three conditions. Only then we can apply DTFS or DTFT. These are the three conditions called as Dirichlet conditions. Only then we can apply DTFS or DTFT, provided DTFS can be applied only for periodic signals, FT can be applied for aperiodic signals. So these are applied for discrete time signals, which is x of n. Both are applied for discrete time signal x of n. Both can be applied for discrete time signal x of n. If we have x of t, then you can apply CTFS or CTFT. If it is periodic, then we have to apply Fs. If it is aperiodic, x of t is aperiodic, then we have to apply CTFT. Okay, this is different. Discrete time x of n, continuous time x of t. This is continuous time. CT means continuous time. Okay, so these are the things, the necessity for DTFT. These are the things, the necessity of DTFT. Now I'm going to the formula for calculating DTFT. It is represented as x of n continuous, x of n discrete time signal in time domain, discrete time signal in time domain. In frequency domain, it is represented as x of j omega, and both of these are called DTFT pair in time domain, in frequency domain. Time domain, frequency domain. These are the representations. These are the representations. So the formula to calculate frequency domain is nothing but summation signal into e power minus j omega n. Signal into e power minus j omega n. N varies from minus infinite to plus infinite. N varies from minus infinite to plus infinite. If you want time domain signal, then it is 1 by 2 pi integration minus pi to plus pi. You have to take the frequency domain signal, then e power plus j omega n and d omega to be put. This is forward direction. First one is forward direction. Second one is reverse direction. First one is converting time domain to frequency domain. Second one is converting frequency domain to time domain. So these are the formulas required in DTFT. Now I will go to problems in DTFT. I will go to small problems in DTFT. Find discrete time Fourier transform of, first case I will take del of n. Second case I will take u of n. And the third case I will just take x of n equal to 1, 2, 3, right-handed signal, with arrow, without arrow. Okay, x of n equal to 2, 0, 1, 4. and arrow mark for the last one. Okay. Now, if you go to the first signal using the formula, formula del of n, okay, is the signal. So we know the formula is x of e power j omega is summation signal into e power minus j omega n. This is the formula for DTFT. N varies from minus infinite to plus infinite. Now we are having the signal as del of n. We know del of n is impulse signal. It exists only at origin. We know del of n is an impulse signal. It exists only at origin. Okay. So we will take the limit n equal to 0 only. E power minus j omega, n value we have to put 0. N value we have to put 0. If you simplify this, we are having the amplitude only at origin, and that height is 1, and e power 0 value is also 1. So whenever you calculate any transform for impulse signal, the value is 1. Any transform for impulse signal, the value is 1. Okay. Now I am going to the step signal. U of t is step signal. The first one is impulse signal. Any transform you apply for impulse signal, value is 1. U of n means step signal, discrete time, it is step signal. So coming to the second one, solution, the same formula we will take. This is equal to summation x of n e power minus j omega n. N varies from minus infinite to plus infinite. This is the actual formula for DTFT. Now in the place of x of n, you put the signal u of n e power minus j omega n. N varies from minus infinite to plus infinite. Now we know step signal, it exists only on the positive side. Step signal, it exists only on the positive side. Up to infinite, it is having a height of 1. It is having a height of 1. And now if you see, I will take the summation limits 0 to infinite, and the signal height is 1, and e power minus j omega n. If you expand the summation for n equal to 0, e power 0, n equal to 1 means j omega, n equal to 2 means j omega into 2, n equal to 3 means j omega into 3, like that. It continues. It is an infinite geometric progression. So sum of infinite terms is nothing but sum of infinite terms in a geometric progression is a by 1 minus r. So I will calculate x of e power j omega using the formula. This is x of e power j omega using the formula a by 1 minus r. A is first term, r is ratio, okay. Second term is ratio because first term is 1, okay. This is the DTFT for step signal. DTFT for step signal is 1 by 1 minus e power minus j omega. This can also be written as e power j omega by e power j omega minus 1, okay. If you write a power minus m equal to 1 by a power m, this negative sign, if you write 1 by a power m, then you make the LCM, it can also be written as e power j omega by, okay, e power j omega by e power j omega minus 1. So first two problems I completed. Now I am going to the third one. This is a right-handed signal. This is a left-handed signal. And here arrow mark indicates n equal to 0. So the first one is x of 0, x of 1, x of 2. So you take the formula x of e power j omega is nothing but summation signal into e power minus j omega n. Equation 1 is the formula. And n varies from minus infinite to plus infinite. But from the given signal, if you see n is from 0 to 2, and signal value is given x of n e power minus j omega n. Expand the summation, n equal to 0 means x of 0 value is 1, e power 0, next value 2, e power minus j omega, next value 3, e power minus j omega into 2. I am just expanding the summation. This is the DTFT for third problem solution. Now I am going to the fourth problem. If you see, the fourth one is left-handed signal. Okay. So D, fourth one. You take the same formula, x of e power j omega summation x of n e power minus j omega n. N varies from minus infinite to plus infinite. Equation 1 is the formula for DTFT. formula for DTFT. If you see the arrow mark indicates n equal to 0. Arrow mark indicates n equal to 0. So this first one is x of 0. Left side it is x of minus 1, n value minus 1, n value minus 2, and n value minus 3. Okay, only this much is available in the given question. So accordingly, we will expand the summation. Summation limits we have to take from n equal to minus 3 to 0, x of n e power minus j omega n. If you put n value minus 3, x of minus 3 value, and here it will be plus 3, power will be plus 3. If you put n value minus 2, x of minus 2 is 0, e power j omega into minus of minus will become plus. X of minus 1 value, power will become minus of minus 1 will become plus 1. And x of 0 value, and then e power 0. Okay. Now x of e power j omega is nothing but 2 into e power 3j omega plus e power j omega plus 4. This is the DTFT for the D. The last question, fourth question we have taken. This is the DTFT calculation for the fourth problem we